All right, hello builders. My name is Jeeve. On to the third part here of our backend example. So in this one, we're going to be starting to work on implementing tRPC. So in the ways that we were doing backend before, we'll do a quick review of how we were doing it before, kind of try not to use as many external services. For the tRPC example, we are going to be using tRPC, tan stack query, a bunch of smaller minor libraries like SuperJSON and Zod and some others like that, kind of providing more of the structure that we kind of created ourselves in creating the safe action and having these features and API calls. Instead, what we're going to do is kind of abstract a lot of that using tRPC, have a lot of type safety built in by people who are, frankly, a lot smarter than me in creating backend code, and kind of work off of what is now pretty much considered the, not necessarily the gold standard, but I will say the leading edge of what's going to be in the Next.js tech stack, what people are going to be using going forward. And I wholeheartedly believe in how tRPC works. I will go through how I set it up in the file structure, as well as, some of the individual bits. I think that you're going to really like it. There's going to be a lot of work in reformatting the structure of our project a little bit to suit the new architecture. But all in all, I think that for performance reasons and for developer experience, you're going to like this a lot more. Let's jump right into it. So just taking a look back at our existing code here, right? There are some things to take note of, right? We have our database stored within, or our database related code stored within a DB directory. We have that all set up within our drizzle.ts file. We have our reference to the NeonDB database that we have set up and is hosted for us by Neon. We have our Drizzle ORM, which allows for us to write in TypeScript familiar code, SQL queries for our PostgreSQL database within Neon. So a little bit complicated there, but we're using Drizzle to provide a bridge and a link between our TypeScript code that we're writing within our Next.js app to our Neon PostgreSQL database. All right, so hopefully that's clear for that portion. Stumbling along my words a little bit there. I apologize. What we have here is a pretty bog standard basic next auth schema that we're representing here in, again, a TypeScript familiar way, right? Instead of having to write out all of our, Drizzle or our SQL commands to be able to set up the tables and all that type of stuff, we just do it within what looks, right, or really like, easy to use TypeScript wrappers. So we have all of our Next.js stored here, right? Most of this examples was talking about, implementing a storage of our user credentials within the database and how we were able to retrieve that. We're going to be doing that same example, but with tRPC. The way that we were doing it before, pretty naive. We were using, for users here, right, our API, which was primarily just getting the user. We had to declare what the schema was for our API call, in this case, get user. What types we're kind of expecting, right? So the schema here that we provided here serves as an input type. We have an output type, which is a action state, which has a data field of type toutput. In this case, we're specifying it to be of type users, which we specified. Not in this schema, but in our Drizzle schema here. So we're talking about this user here. And then the input type, right, was just the input type that we declared here. Technically, we could have put this here, but we needed to export it, so might as well have it as its own separate thing. And so that's our output type. Both of these, not this one, but this schema and this types file combined allow for us to utilize this index file, right? And by using index here, we basically, let me actually zoom it in a little bit. The purpose of this index.ts here is, instead of writing get user, right, and then having to create a extra type of import. So if we went into, I believe home is where we have this, right? We have @/features/users/API/getUser. If we didn't have index here, this index basically allows for us to alias, right, get user here at the end with the index file. So basically we don't have to write an extra thing. If we named it anything other than index, we basically lose that, and then we'd have to include it, right? So if we renamed this to function, for example, right? If we update our imports here, VS Code's going to do it automatically, just so you can see there, right? It adds in this extra function to match this file name, right? But, you know, some of those can get a little bit long and unwieldy, especially when you have multiple files within the same directory there. You don't want to accidentally import the wrong thing, right? Especially when there are these .ts files instead of like .tsx, where you can remember that. Makes it a lot easier to just do index. You remove that, just have get user, and then it knows that, hey, this is the only file that we should really be worrying about within this directory in a different import. Cool. So hopefully that's clear. And inside of this index folder, or file that we were using, again, the input output from types, we have a reference to users within our schema. We have the get users schema value here, which is just looking for user ID. And then we use that within this handler, right, that takes in that data of input, provides a promise of an output, because, you know, API calls can take a certain period of time, right? We're pinging against a database, and so we're going to try to allow for, you know, some amount of time between that, right? Internet, these are physical devices, so it takes a potential amount of time. And so we provide a promise, which we promise to resolve. And that's why we have the asynchronous. We allow for other things to happen so that we don't bog down our application waiting for the response. When the response eventually comes, the promise resolves and then becomes some form of value, right? And in this case, on the evaluation, it's either an error, user is not found, or some form of valid data, right? And then we wrap this within a create safe action function, which is a complicated piece of code using templates and all that other stuff there. But eventually it provides a T output, some form of error, field errors, all that type of stuff that we might need in a typical API call, right? Whether it's a mutation, whether it's a query, right? So in this case, this was a query. We are providing some form of input data. Technically, the input data could be optional, right? If we were trying to get all users, we don't really care about the IDs at that point, so we can just leave the input blank, right? We don't need an input in that case. If we're just finding all users, we don't need to search via any user ID, then we don't need to provide an input. In this case, we're finding a specific user. We need to provide the corresponding input type, or input type. And as you can see, we do the comparison here. So, given that, right, we have our get user function here, which within our page.tsx, we call, we provide the user ID, which underneath the hood, I copy pasted it from our database. Technically, for the most part, you wouldn't really know, but just for the sake of example, we did this. All right, cool. And so, we were able to call that, and then we displayed it, and I believe in the last example, we do it. Let's just, for posterity's sake, do npm run dev, and make sure that it's working. All right, so just to test this out, I totally had forgotten that I had deleted the database connected to the background between the last time that I worked on it and now. So as you can see, the user is not found because I deleted that database. I had to quickly spin up a new database to make sure that we get this. So we have a different user ID. The new ID is as follows, something totally different, which I'll be deleting after this tutorial. As you can see, when we do this now, we have my email showing. Great. So we verify that it works because it's able to communicate with L database, and as you can see there, right, we have our information here, right? So cool. The same ID, the email, and all my information from my login attempt. Cool. So now let's move on to swapping out all those kind of, as my old professor, computer science professor, would say, this kind of guts out approach for more of a black box abstracted approach, but I think will ultimately result in a better developer experience. Let's jump into it. All right, so tRPC, what is that? So ultimately, when we want to talk to our backend, right, we utilize something called an API, an application programming interface, right? It's how our code is able to interact with different web services. And in the past, we used to use tools like Ajax and jQuery, and while we can use it, it starts to look a little bit different than our typical, TypeScript code, along with the fact that it was designed for JavaScript, and so type safety is something that is a little bit harder to enforce, right? It's not impossible. There are ways to do it. It's just that we kind of want it outside of the, out of the box, right? We don't want to configure it every single time. And so with tRPC, we can write APIs that we can call and use, right, with type safety as being kind of a central core piece of it. Right, and so you might have remembered just in the previous examples, right, in the last video where I was just doing it in a minimalist, no frills version, right, I had to create our own schema, right, and create our own types for us to use in our API calls. So with tRPC, we get it out of the box, right? We get all the type safety that we want, and it's automatically inferred. And when our project gets bigger and bigger and our schemas get bigger and bigger, well, the system is already designed to deal with that. And so I honestly recommend using it in going forward. I've used Hano in the past, and honestly, I find tRPC to be a lot better, also a lot faster. And so, maybe in the future something comes out with Hano, and it totally beats tRPC, but honestly, there are some features that are totally different between the two that there might be a divergence in how you use it. And so in the style that I teach and currently use for products that I'm developing and building, tRPC makes a lot more sense. And so, these are the documentations. If you want to get a deeper dive and kind of understand it a little bit more beyond what I'm kind of talking about, I'll have the links in the description of the video. So one of the things that we want to look for, right, here is how it's being used with React server components. So we also want to make sure that we're looking at tRPC version 11. That's, at the time of recording, the latest version that is out there. So we're going to be using that. I know that there's a Next.js tutorial, but honestly, I think that this one is the most succinct and kind of the best understood. I also noted that, while I'm recording this, just coming out is TanStack React Query, and I know that a lot of people are very excited with it. I haven't personally used it. I'm going to take a deeper dive and take a look at it. Maybe use it in a different project I will be using it in a different project just to see how it works. And probably you'll see a part 3.5 for this just on tRPC plus TanStack Query. But for right now, we're just going to be using, as they denote there, right, the classic React Query integration. So there's a lot of pieces to this. I'm going to be working through it step by step. For new people, it seems like a lot of steps. And honestly, when I first saw it, I'm like, oh my gosh, like it's really complicated to set this up. But then it becomes muscle memory, and it's kind of the same thing as like setting up Next.auth, right? You're just like, okay, I just need to create this here, and this here, right? And ultimately, it's a lot of copy paste at some point in the future. I'm going to be doing some form of that, just because I configure it in my own personal way. And so it's kind of like, after a lot of, scar tissue and calluses, I figured out this is the best way for me to particularly use it. You're welcome to follow the documentation extremely closely. And again, I'll have it in the comments down below. But I'm just going to show you, right, in a way that like very closely mirrors the documentation, but with some of the, I won't say expert, opinion, but kind of what has been useful for me, right? So it's going to deviate a little bit from the documentation. Hopefully you'll still be able to follow. The first steps will be, of course, to copy this command, and there's unfortunately no copy button, so we'll just have to go through and grab all of this and just copy it. So we're back in our VS Code. We're going to paste the command that we copied into our terminal. And so we're just going to run this. And we're just going to look at the different pieces going on here, right? So tRPC server, tRPC client. So for use with server components and for use with client components. So the structure here, right? You can't use a client component in this function, even though you're trying to enforce authorization here with protect page. This can never have any client component stuff in it because we have an asynchronous function here. It just doesn't work for now. Maybe in the future they'll have a way of doing it, but you can't declare use client on the top here, right? And be able to use stuff like a basic thing would be like const, user use state, right? You can't do that. You'll require for this to be a client component for you to be able to use state, because state lives in the browser on the client, right? But unfortunately, asynchronous calls are done on the server, which is, if we're deploying on Vercel, if you're deploying on the cloud, it's in the cloud, right? On some server that AWS, Azure controls, right? So obviously those two are not in equal locations, right? Your browser is on your own computer, the server is somewhere else, right? So they obviously can't interact with each other in a very clean way. So we also have to separate how we interact with our APIs when we're using either in a client component or on a server component. So hopefully that helps you understand why there's two of them here. React query. Again, TAN-stack is a different way. We'll maybe look at that in the future. Depends on how I feel about it. There is TAN-stack React query still in here, but it's not being used as the main part of it. Zod is for kind of type management. So for matching types. And so when we're using something like tRPC, because we want type safety, right? We want strings to be strings, numbers to be numbers, booleans to be booleans, right? We don't want to have a bunch of mismatches, and we try to avoid using any as much as possible. And honestly, most modern I'll call them compilers, web compilers, and they're actual web compilers now, but npm run build, right, should break if you're using any in your project. Zod helps you make sure that, like, okay, strings are strings. It could be strings and this other thing, but let's make sure that we explicitly declare it, right? Make sure that when we're calling something from the API, we make sure that we're expecting the same data type. Then we have client only and server only. That's some tRPC related stuff. No big deal there. And so, yeah, those are the things that are added. We've installed all that stuff. Let's go to the next step, right? So create a tRPC router. And so it says to initialize your tRPC backend in a folder called trpc/init.ts. Using the init tRPC function, create our first router. They've created a real little simple hello world one. And again, this is where I'm going to deviate a little bit from the documentation here, just in the way that I personally use it. You can follow the documentation and at this source level, just create a tRPC folder, right? And ultimately, I do create one, but it's not for the backend that we're about to do. I actually put the backend in a folder called server, and I'll take my DB folder here and actually stick it into server, right? And so my Drizzle initializer with to reach out to my Neon database, right? So my Postgres database that's stored on Neon, it's going to be stored within the server directory here, along with our schema. And in this case, this is just the basic NextAuth, authorization schema. So those two things now I've added in there. We don't actually need this stuff anymore. So what we're actually going to do is get rid of it. So yes, we're going to delete it. And so unfortunately, this stuff no longer works. What I'm going to do is just comment this out, and I kind of want something similar to occur. So we're going to have a bunch of errors, and so I'm not going to fix those until later. Nothing happens yet here, but we'll come back to API. So this protect page functions in Auth. I'm actually going to take it and take this part here and actually move it somewhere. So recently, and even between the last time I recorded and now, I've actually started and actually can get rid of this features folder now. Don't need it anymore. Go into my auth.ts file. So if I just collapse everything again, source auth.ts here, right? I already have all the pieces that I need to be able to execute this, right? Or to execute the function of protecting my pages. And so I'm just going to put it here. All I need to do is add in my redirect function here from next/navigation, bring it up here, and this is now my new auth.ts. I'm going to control all of my authorization from auth.ts. I'll call it from there. If I need the session from auth, right, just this because I need to pull user data out of it, then I don't need this protect page because I can handle it myself within the function itself. But instead, I can call auth from the auth.ts folder, or I can call protect page. It's all from the same folder, and it makes a lot more sense to me to have these combined instead of its own feature/auth/functions file. And ultimately in auth, really, for the most part, it's the only function that's in there, or the only component or anything in there. So ultimately, since I'm switching to tRPC and I'm not using features for most of that stuff anymore, I'm instead going to be worrying about protect page inside of my auth.ts file. So a little bit of spring cleaning there. So just cleaning that type of stuff up. Inside of hooks, we have just the Sonner Toast stuff, which I believe they just updated as well. So Toast is now deprecated, but we'll deal with that in a different tutorial. It'll come up that we'll use Sonner in a different way. So we have our server/DB. So what we're going to do inside of server here, create a folder called tRPC in here. So you can see, again, I'm going to collapse everything and open it up just so we can all see. We have DB, again, with our Drizzle and schema. By the way, I also turned my drizzle.ts into index.ts, but just for this tutorial, I'm just going to leave it Drizzle, but that's another change that I've made in more recent projects. Inside of this tRPC, though, we are now going to create the init folder. So what we're going to have is, just like I was talking before, with the difference between tRPC server and tRPC client. Server/tRPC/ the stuff I'm going to use in there, right, is for server components. tRPC out here, and it's going to have a file in there, spoiler alert, called client, which will hold the use client version, right? So when we declare or use a client component, we're going to call tRPC/client. If we need the server one in an asynchronous function, we're going to call server/tRPC and use the things in there. Hopefully that makes it a very, safe and clean divide, because before it was like, oh, we're going to use tRPC. Well, which tRPC instead of the tRPC file are we going to use, or folder, right? There's tRPC slash nothing, right? Because it was an index.ts, which we're going to create later. Spoiler alert again. Or tRPC slash client, right? And it would always automatically use the one inside of the index.ts one, totally ignore the client one. And if you're just like me, a cursor, vibes coder, well, also, intentionally coding and just IntelliSense tabbing something in there, right? It'll very often default to the server one, even if you're in the client one. So by this way, I can definitively see, right, remember, use the one in server components, use the one that has client in the route or in the path name for client components, right? It makes it a lot easier for me. In some cases, you might want to switch around the names. So it's client slash tRPC, with tRPC being the file name, but maybe like I would hesitate to have a file or a directory just called client, but maybe there are some other stuff that is only on the client, and then that's where I put extra stuff in there, and so then it makes sense to rename it. But for right now, I just have a tRPC directory here, right? And we're going to do client stuff in there a little bit later. But for right now, we got to worry about init.ts. So first, we're just going to copy this. And I futz around a lot with it. So some of the things to talk about, right, is that with tRPC, we have a tRPC context, right? So just right off the bat, we're creating one. And it's a cache, right? So we're caching some data. We're storing some stuff, right, on the server in a way, but it's only going to be alive during the instance that we're currently using it, right? If we navigate away to a different website, or we try to come back to it a little bit later, the cache is not guaranteed, right? And so, we'll hold specific pieces of data in there, right, that we might be using throughout our application for API calls. So it's very useful in kind of holding certain pieces of data on the server side, right? Client side, we just hold it within use state, right? So this is a way of us being able to have some of those nice features, right? Another thing that I will note, right? So we have this thing called base procedure. And, in Hano and in other places, like if we're using Clerk, there's middleware that you could be using, right? And for us, right, we want a way to be able to write API calls that have authentication in them, right? And you could just within your API call do it every single time, like, check to see if a user session exists and all that type of stuff, right? It's the same thing as protect pages. Well, in tRPC, what we can do is create export const protected procedure, right? And there's a little bit more code to it, so let me pull it up for my own reference. Right, so t procedure dot use t.middleware, so we're adding a middleware now here, and inside of our middleware, it's going to have an arrow function passed to it with our context and next object. So inside of the context that we provide here, that's ctx here. So if we hover over this, let me see what's going on. Let me finish this arrow function first. I think that's what's causing the error. Yeah, so we need to actually write a valid thing. So just so that you can see, right, ctx dot. So what's inside of here? User ID. I think user 123 user ID right there. So that's why IntelliSense is kind of already getting that. I'm not 100% sure why it's not able to see this. I think it's just because of the IntelliSense error right here that it's kind of overriding everything. Let me see, user ID. Let me see what's going on here. I think I need to, well, so I'm actually just going to set the context, and I think this will make it a lot easier to understand. So that it's just adding in a random value here, right? And if you want to learn more, there's a URL here for you to investigate this further. What we're going to do is, inside of our middleware here, or inside of our context here, we're just going to do session is equal to await auth. So this is just kind of similar to our protect page function, right? And what we're going to return is two things. We're going to return our DB and our session object here. So we're just going to return it raw and allow for someone to be able to use it. Now we're going to need our DB, right? So this is, again, our ability to utilize DB to contact our Neon page. So we're just passing that into our API calls. So instead of just calling it from Drizzle, this is a way for us to use it within our protected procedures. So we're going to call at server / DB Drizzle. Yeah, not really a reason why they shouldn't be in the same folder, but you know, I think it's a lot cleaner to just have this @ server notation. So let's see here. So we're not going to have user ID. Instead, we're going to have .session. We're going to have ctx.session.user, or not ctx.session.user.email, or not ctx.session.user.id. So this is the kind of user validation, right? We're going to throw new tRPC error. So we're going to be using tRPC errors to basically do error reporting. And we're going to pass in a code here, right? And we're going to call it unauthorized. Great. And then if we're all set, then we're going to return next and then ctx. We're going to return our context. Whoops. So there's that. We need to provide, let me see here. That's right. What we're going to do is type our context here, because we've declared a custom one, so we should declare a context type. We're going to do DB type of DB. You don't want to write it all out, so we're just going to shortcut it that way. Like, I don't know if you want to copy this with, you know, this stuff here, just type of DB, and then session, right, which will be of type session from NextAuth. Thankfully, they already have that. It could possibly be null if someone is unauthorized. And inside of our init tRPC, what we're going to do is .context, provide the type that we created there, and then .create. And now you can see all the errors are gone because we passed in what the context looks like to our tRPC. Cool. Awesome. It didn't have that in the base documentation, but in this way now with our and you're going to see it in the future when we use the context variable, we're going to have access to the session, so we know if we're authorized or not. Technically, if we're using protected procedure, we should always be authorized. So great. Then that means that we can use the session to get our user information within our API calls, which is important, instead of calling it directly from this auth function, right? Cool. So we don't have to rewrite that over and over again. We're just going to have that automatically in our context. Cool. Next thing that we're going to do, and if we're just going to follow this documentation here, we need to create our routers, right? So before we had it inside of features, and we had a bunch of APIs, right, within our features, right? So instead, we're going to store them in routers. And so this matches more of, you know, if you're more familiar with Hano, more of like a Hano thing. with routes, right? API routes. And so instead we have routers, which store all these routes together. So you could copy this one, and I guess it makes sense. So we're just going to copy this. It's weird that the copy is here for this, but not for the installation command. So what we're going to do in here is inside of our server tRPC folder here. Whoops, not new file. We're going to do new folder. We're going to create routers. And inside of routers, we're going to create a new file underscore app.ts. We're just going to paste this code in here. So what you're going to see here is that we're using a base procedure here, right? And when we're using the base procedure, not too much of stuff. We don't really get to use our context or next. And honestly, I don't think I've really used next that much. But let's just pretend and create protected hello, right? And use protected procedure, right? We're just grabbing it all from init dot query, right? We're gonna have access to our CTX, our context, right? And if we hover over context here, you can see that we have access to our DB and we have access to our session. And so as you can see here, does not exist on. Let me check something real quick. I think it's how you're supposed to type it. So let me just grab an example. Right, there's some extra stuff that we have to do. Let's see here. So first of all, this is an asynchronous function. And then another thing is that we need to wrap these in curly braces so that we can actually use it. So we're extracting the context out of its object. Cool. And so, yeah, we can grab, so this just allows us to see that we can grab, session, user, email. Cool. And so, let's see here. If you're wondering why, you have this question mark dot user question mark, right? It's because when it returns, you're returning basically the same thing as this context here, right? You don't have the validation. So if you actually wanted the validation, what we can do is just grab the pieces that we want, right? So we can just return CTX colon. We can return the DB, something that we're going to use, and user, which will be, and we can honestly format it in the way that we want. So user has a bunch of pieces into it, right? We have the ID, so ctx.session.user.id, and let's see the type. Let's make sure that it's correct. It should be of type ID. Yep, see that? So we don't have a confusion of oh my gosh, do we have it or not? Well, we have this checked version up here, right? But unfortunately, if we just pass in the same context value, well, we're going to lose that, right? So we have our email. I think name is another one in there. And what's the last piece? Image. That's it. Image. CTX user image. So those are the pieces. I don't use email verified that much, to be completely honest. You can use it if you'd like for two-factor authentication, all that type of stuff. I just trust in most of my applications, just use Google in the auth. But if you were to use email password in yours, then maybe you want to do your own two-factor auth. Cool. I particularly don't need it. So in this case, right, we don't need to provide some of this stuff. Instead, we do just user and dot email, right? So now we don't need to go through all of the session stuff. It's still in there, right? And so honestly, technically, we don't even need to pass in DB, right? We can just pass in this stuff, and it kind of folds it together so that you can just see there in the context, right? We have this user, and we have session, and we have DB, right? We didn't check our images, right? There was no check for images up here, so images could possibly exist or not. And we didn't do the same thing for a name check. So if you wanted to check, just add another or condition here, check for one of those two things. But in some cases, hey, for whatever reason, I think most people should have a name, so it should be a pretty simple check to check for the name, and should never really error out. But hey, maybe you want to be able to catch those cases. And that's probably a good thing that you catch those cases. If for whatever reason Google messes up, it's not on you, right? That you're having a problem, some sort of bug happening when name should be there, but it's not, right? You don't want an an authorized person who signed in validly to be prevented just because of a mess up on Google's end. So we have our protected hello here. Another thing is we can do await. Remember, since this is an asynchronous function, we could do await ctx, right? .db dot whatever we want. We can insert stuff. We can query stuff. Whatever CRUD, right? Create. What was it? Create, remove, update, and delete. No, delete. Yeah. So what is R? Create, remove, update, delete. No, but D's delete. I forget whatever R is. Look up CRUD, or I can do it real quick. What is CRUD? CRUD operations. Read. That's right. Right. That's the get function. Cool. So create, read, update, delete. I had a brain fart there. But yeah, so you can do that, right? That's your queries, that's your deletes, right? And then your get is your query, your insert, and then you can update, right? So that's all your CRUD functions, and they're all stored within your context. So, hey, maybe if you create a function and you pass context into it, context can carry it around, and you don't have to import, DB everywhere. So that helps control access to query in any particular way, right? So just more flexibility for advanced users, for most regular users, right? Whether you're importing it or you're not, functionally not too different. There are some particular things that people can argue, and they will, about like, oh my gosh, you need to use it in this particular or the other way, right? Do what works, right? Working code works always. That's always the most important thing. Then beautiful code is next, but if you don't have the first thing, you'll never have the second thing. So beautiful code that doesn't work is useless. Cool. So we have this app router. Now I'm going to deviate a little bit from the documents just because we want to come back to the fact that we need to do get user, right? And look, I can just do get user inside of our app router, right? And just do get user and do a protected procedure, and we can query async, right? Again, we're gonna do ctx arrow function, right? Here, make sure that you do a comma, not a semicolon, and then all we're doing is just return. What was it? Just the email? You only needed the email? Okay, yeah, I'm just gonna return the email, right? ctx.user.email, right? And we're just going to name it email. So that if we were to utilize our code here, right? This is on the server side of things. So we're going to have data is equal to await, I believe. Let me just check to make sure. Where do I call it? I think it is just tRPC. Oh, I haven't done it yet. Okay. Hold for a second. I can't do this demo just yet. So we need to go back to our documentation. Just remember that I'd already created the get user here, but eventually app router gets pretty slammed with a bunch of API routes, right? If you just kept going, the file would get absurdly long. So there's an easy way that we can fix that. We can just create a user.ts, right? Export const user router or auth router or, auth router. You can call it whatever you want. We'll just call it user router, right? And then create tRPC router, grabbing it from /init, right? And all we need to do, just copy this get user, actually cut it out of there. We can paste it in here, right? all it needs is our protected procedure, also from /init. Let's just make the style look a little bit better. Pretty clean file there. And then all we need to do is add it to our app router. So we're going to have user router, colon, and let me see here, make sure, yeah. So user router, right, from /user. And then our app router has access to hello, protected hello, and then user router. Cool. So that's a clean way of doing it. Let's go back to the documentation so we can finish this and actually get this example working again. Let's see. So last thing is, in our APIs, make sure you don't forget this. You're going to get 404 errors if you don't remember to do this, right? And sometimes, because it's pretty easy to remember setting up your server file or your folder, and then you set up your own tRPC, and then you forget about doing the API stuff, and then you're like, oh my gosh, why is the API calls coming with 404s? Do this part here, and that'll solve that, right? And look, there's some, tildes here that cause some potential issues because they're using tildes, we're using ats, so make sure that you clean that up. Now let me make sure that everything looks the same. Let me see, what does it look like for me? Yep, so it's just basically the same thing, but just with at instead. So what we're going to do is inside of our API here, right? API, at the API level, make sure that you don't accidentally put it within auth or next auth here. It should pop up at the same level as auth. We have our tRPC. Inside of this tRPC folder, we're going to add in with curly braces without ... So it's not the same thing as next auth. tRPC. So the curly braces without the ellipses, just tRPC inside of the curly braces. And then add in a new file, route.ts. So all we're going to do is copy this code in here. And I believe all we need to do is /server tRPC init. And then do the same thing here, /server tRPC routers. This is our app router. Again, the one that we were just working with. Honestly, I can put all these together, reorder them in ABC order, bring this one down one, and yeah, everything else can be the exact same. That's all I changed, was some of the imports and moving stuff around for ABC order. I could technically move this in ABC order. Doesn't matter too much. But just makes things look better, in my opinion. All right, cool. So we're one step closer to actually fixing this. The next thing that we're going to have to do is, let's see here. That's actually interesting. Yeah, so a thing that we're going to use is something called super JSON. And so you might see it commented out here. Actually, should I do that step? Oh, well, I'm going to forget about it. So we're going to do the super JSON now. So what is super JSON? Well, sometimes you might have come across this, especially if you've used in the past, right? Drizzle and Neon with, Hano or some of the other APIs, right? You might notice that if you have a created at field or some form of date field, right, the dates don't match, right? Then you'll have to redo the new date at, right, or parentheses. Maybe I should just write it out. Like, let's just pretend in user here we had like user.created at, like a created at field, right? And the way that you would have to do it beforehand would be like, const normalized user is equal to, right, and then like all the other fields, and then created at new date existing user, and then like all the types would match up, right, whenever we were using this stuff. And then you'd use normalized user instead of user, right? And so it became a whole tedious mess. Super JSON fixes that. So now in our API calls, we're using the same data format, or at least that's how I understand it. The data format is similar. So what we're going to do is npm I super JSON, right, to be able to just use it. Let's see if we require force. We don't require force. Great. So it's updated to React 19. And now we can comment this out and import it. So let's just reorder some things here real quick. And let's see. What is the exact import statement? So it is a top level one, because what we're going to do is import super JSON from super JSON. Cool. So they exported defaulted, so that's why it doesn't appear in these curly braces. If you really want to be pedantic about this, you can also add type in, right, to be like, hey, session is being used as just a type, right, not as a value. It doesn't matter, right? You saw that there were no build errors or no issues between that, but, you know, code cleanliness, code styling, maybe you want to do that. Cool. So now we have super JSON, so that when we go over to work on the client, because now that we're done with our backend, so we can collapse this, now we need to create the client side, right? And so again, they say tRPC / query client, so I'm going to 100% agree. Oh, whoops. I'm going to copy actually the full file name, so that inside of our tRPC folder, I'm going to collapse everything again, get rid of init, let's collapse everything again, open up tRPC, this tRPC folder, new file, paste the file name, query-client.ts, right? And copy this bit in here. And we have already our import super JSON from JSON. And what we're going to do is just comment out some stuff. So serialize data and deserialize data. So these are all automatic things that you know, are going to be taken care of for you, so that you don't have to. I know they call it serialized. I call it normalized. It's, again, personal preference. I think theirs is probably more descriptive, better, because normalizing data is technically a different thing in mathematics than serializing, I believe. But, you know, hey, I don't have to worry about it anymore. I'm not going to use that variable name because it's all done and set up for me in here. Let me just check between my source code, starter code, if I made any other changes. Doesn't look like it from a glance. And so, cool. Next thing is to actually create our tRPC client that we can call. And also there's a bunch of like, hey, there's some default options. They're discussing that here. For me, honestly, in all my uses of it, all these default options worked totally fine. So not to worry about that. And now we need to create the client one. So we have our query client, but now we actually have to create the client that we're going to be calling. See, with use client already involved. So what we're going to do is just copy this, create a new folder, client.ts. Actually, it's tsx, because we're going to have some JSX in here. As you can see, we have our provider here. And so let's see here. What's wrong? Collides with the built-in method. So there are some issues. First off is that this is now an @/server server/tRPC routers app. IntelliSense was wrong there. Let's just reorder things so that everything is in ABC order and things are filtered correctly. So we're just going to move these things around, and yeah, sure, that's fine. Cool. Let's see what else is there. Yep, so we need super JSON, so we're just going to uncomment this real quick. We're going to need to import super JSON, so it's going to be right at the top. Import super JSON from super JSON. Great, don't need that. And you can see that fixed all of the errors. So cool. Something to notice here, right, that like if you're deploying on Vercel, right, they already include the Vercel URL here inside of your environment variables. So you don't really have to worry about that if you're on Vercel. They also have this version for if you're doing it on the local machine, like we are doing our local host, right? But when we deploy it, Vercel automatically has a Vercel URL. If you're using this on an off Vercel platform, then please, you need to provide the URL that corresponds with the service that you're using. I will be using Vercel, so I'm going to leave it intact, but all the pieces that we're going to need are in here. We have tRPC from the client side, and we have tRPC provider here. So cool. We have all of that stuff. I believe we're missing one more file inside of our tRPC. It should be a index.ts file. We'll get back to that in a second. What we're going to need to do to finish off the client is there's this provider, right, that we've created here, this tRPC provider. And on the client side, whenever we want to use tRPC, we need to invoke this stuff from within this provider. And so what we're going to do is just go out to our layout here, right? And in between the body tags here, we're just going to add in our tRPC provider. And then wrap child in there. Cool. And now we're able to use the client side tRPC within anything, right? Because we're on the top level layout, right, within our app router. And so at the top level, we provided our tRPC provider. So any subordinate and including the top level page.tsx can now use the client tRPC to make API calls. Wonderful. All right, cool. So we can close down this stuff, including the layout. And now I believe I missed the index.ts somewhere. There's a init. I thought I had that. Let me check in my source code if I included it. I do. Weird. Did I miss it somewhere in the... Oh, no. Okay. Phew. I'm not an idiot. That's the last version. Okay. All right. So they use tRPC/server.tsx. That's why there's a difference. Okay. So with index.tsx, right? That's our last part here, part 5. Okay. So the last part, right? That index.tsx. So they call it server.tsx within that tRPC. Look, if it makes sense to you that there's tRPC/server and /client, great, right? For me, this makes a little bit more sense to me, right? To separate all that stuff, to be able to put DB with all the server side tRPC stuff. Maybe it doesn't, make sense to you. Feel free to structure it in the way that the documentation says, if that makes a little bit more sense to you. This makes a little bit more sense to me, so that's what I'm going to use. So inside of this index.tsx, we're going to be using similar stuff to server.ts. And I believe I accidentally made this index.ts should be tsx, so just amend that real quick. Query client is unfortunately in @/tRPC/query client. Cache is going to be on the top level, and this is going to be on the same level as our app router. Technically, I mean, we could, do @/server/tRPC, but, the router is always going to be with the server side tRPC stuff, so I don't see a reason to do that. So yeah. Cool. So this is where we're going to be able to use our server side tRPC. That's why I was missing it when I was trying to use it up here. What is this? Lucid React user. I don't know why I imported that. That was by mistake. Also, this protect page is in a different spot. So we are going to, honestly, I can remove this stuff, /auth, and now it's just auth like that. Right? On this app, so we need to modify that. So @/auth, and then get rid of the stuff at the end of here. Cool. And I believe that should work. All right. And so we go to this. Let's zoom in. I think it was 150 was the sweet spot. Log in. And, oh, our login page, we need to also fix that. Where is it? Yep. So we need it at /auth. Well, yeah, we didn't actually move it, so that's why it didn't auto import. So now this works. So if we wanted to replicate this behavior, we're going to have to do it in a particularly different way that matches how tRPC kind of interacts with things. So there are things that are going to be called within the server side, and then there's stuff that's going to be called on the client side, right? So when we need to render data that's going to be brought to our browser, sometimes it's best to prepare it on the server side, but then be able to move it over to our client. And when we receive it from the client, right, based off of what we have in the server, we'll have all of our error, our loading states, all that type of stuff built in. And unfortunately, we can't do it within our asynchronous function in the same way that we did it here, right? And if you saw the ways that we usually do it in Hano or with tan-stack query, we need to use client components to get stuff on the client, right? And so, unfortunately, we can't mix and match the two. So what usually the convention that I follow is creating a folder _components, just like we did for login, right? Here with our GitHub and Google login, that's how we were able to use client here for our synchronous pages. We're going to do the same thing. So we're going to create a just home contents.tsx. A lot of people call it a bunch of different things. I just call it contents, right? We can do export const home contents here. It'll be in a use client component, right? And then here we're just gonna pull in this home contents. We haven't returned anything, so that's that error there. We're just gonna move this stuff into the home client so we just remember what we're trying to do. And let's just for now, right, return something similar to before, right? Div well, yeah, sure, that stuff, but also user email, right? Some form of email that we'll grab in the future. And so how do we grab it, right? So we're grabbing stuff from the client. It's going to be different from how this worked. Async is definitely not going to be used, right? And so what we're going to do is, let me just grab the source code real quick, but I should already know this. Const user email, or I mean, I guess I'd call it get, well, yeah, just email. Oh, actually, it's going to look weird, and you'll probably see why in a second. Get user is equal to tRPC dot, and now it grabbed it from the client. Great. Dot, just grab the right one. Where is it? User router dot get user dot use query. So it's something that somewhat you know, wordy in a way, but it matches the modern convention with tan-stack query and other stuff to be able to call use query for kind of the get functions, the read API calls, and then use mutation for anything that causes changes, right? Mutations. And that's your creating, your updating, and your deleting. So you use mutation for those and use query for these. So we need to pass on the same thing. So thank you, cursor. We just copy in that and put it in there. And so now get user, you can see that we have potential errors, right? The input user ID of string, our output email, and email colon. Oh, why is that user? Did I make a mistake? Let's see here. Weird. Why does it also? Why is email of user? That's not right. Not 100% sure. Oh, no, because it's, yes, because I grabbed the whole user here. So dot then user, there we go. Yeah. That's exactly what I want. User, if it exists, extract the email so that we're only grabbing the email. That was my mistake there. Cool. So this should filter out, right? Null or undefined. So we're guaranteed to return an email. So if you look here now, okay, yes, it looks right. The input, user ID, string, output gets me the email, and we could have some form of error, right? So to have our error state will be get user dot, right, error, and then we can print out the error if it exists. And that's pretty rare. Well, error dot data, or message, sorry. And we didn't actually provide a message, so let me see actually. Data, I think a message. Message should be fine. So it's a string, it matches. If you really wanted to customize it, you can do it all inside of here. For email here, we're going to do get user dot email, or get user data dot email. I guess we could also do with the error catching, right? Not get user dot data. So if data does not exist, well, oh, actually, yeah, that's a problem. Sorry, I'm mixing the two things, right? Because if it has data, then error doesn't exist. So what we're gonna do is else if not get user dot data, not a loading state, but we actually have an error. We have an issue here, right? And I guess another thing before that, right? Else if we want to have a loading state, if get user dot is pending, right? That's our kind of loading. I think actually, did I just see is loading? Yeah, is loading also exists there too. That's for the first fetch, right? But is pending, I believe. If there's no cache, so there's a difference there. I mean, you know what? Just for the loading state, we're gonna just call is loading. I think that actually makes a lot more sense, right? And that'll be the loading. And then we don't actually need this question mark here for email. So great, we have all those pieces. And look, you could extract it out individually, just like the way that we did it before. We can pull data here, we can pull error, we can pull is loading, right? And then we don't actually need to have get user over and over again. And I guess technically, right, instead of calling it data.email, well, I don't want it to be email.email. So, okay, yeah, this works better. You know, data.email, right? Or you could name it whatever you want, right? But, cool. And yeah, so it's guaranteed a string, but like, you know, if technically like, oh, if you were returning email or undefined, or string or undefined here, you could technically do like not data.email, but email is guaranteed to be a thing. If this works, it doesn't return an error, then, you know, we're all good there. So we have everything should be working. And if we switch over, and because I added this extra bit, you know that I properly refreshed it. There we go. We have our user email and we have our information there. And look, if we sneakily underneath the hood, didn't change the name of email, but, you know, just returning the ID. Refresh. There's the loading state. There's the ID. And then we have name, right? If we save that, refreshed it, long-ish loading state there, right? So, you know, we have all the information. I know that it's named email, so let's go back to making this an email again. You might have noticed that it took a little bit of time. We were able to see the loading state before this all appeared. Now, for this trivial example, we might not see the benefits too much, but one of the powers of using tRPC is we can add an extra function to it, or a function call, inside of our asynchronous function that pairs our page with the contents. If we have some form of query here, and let me just get rid of this so this is more clear. If we have this query, we can prefetch it, and we can prefetch it inside of the asynchronous side. So this is on the server, right? So if the server is able to pull the data so that when the server gives all of the data over to our browser. We've already prefetched our data on the server side, right? Makes it a little bit faster so that we have it already pulled and ready to use when we pull all the stuff that we need to render a particular web page, right? So it's all brought in at once instead of like, here's your website. Oh, you need some data. Okay, here's your data, right? And so that's kind of what the delay was. So what we do instead here, right, is call tRPC. But see, we go over to the server, right? We don't want the client one. We want the server one, right? So we're going to pull it from /server/tRPC. And we're going to do trpc.userroute.getUsers.prefetch, right? So we're just going to call that. And it requires some arguments, right? So we need to be able to have the user ID. And so we're just going to also provide it here. And so if you were to see this, right? I mean, I don't know if you can notice how fast it is, but in some cases you might see the benefits, right? But yeah, like on a larger bulk pull, right? It's noticeably faster. So cool. Maybe I'll try this. I'll restart the server and see if that actually helps things. So let's just refresh. See if maybe that changes something. If not, loading. And then it appears. Loading. I mean, that feels kind of snappier, right? There's still a loading state. You can kind of see it. But, yeah. Probably like 2 seconds, 3 seconds turns into 1 second. And honestly, for the loading of a website in the modern day and age, you know, that's kind of what people kind of expect. So, when there's large, bulky pieces of data, it becomes ever more so noticeable. So hopefully that really shows you the power of using tRPC. There's a lot of advanced stuff that you can do with it outside of the scope of this kind of beginner tutorial, but you'll definitely see me using it in other tutorials in the future. And so do try it out, play with it, you know, feel free to use the documentation here as a guide, right? This is the classic example using just React query. In the future, I'll probably, you know, as I'm using this, maybe I'll want to use TanStack query or TanStack React query in the future. So I'll definitely try it in a project of mine on the side, see how it works, and then come back with maybe a part 3.5. But this wraps up part 3. Hopefully you can see the power of using tRPC, right? Instead of having to write the schema file and the type file and be able to juggle all that stuff, right? And, oh, if I made a change here, I made a change there, then I have to go back and change a bunch of different files and stuff. And hopefully, you know, not having cascading feature thing and, you know, having to add in all those extra files, right? I hope that this, in your mind as well, cleans and clarifies a lot of things. So, go out there, build some really cool APIs and backends now with the power of tRPC. And just remember, if G can do it, so can you. Go out there and build some really cool stuff. I'm excited to see them. If you have a link them down in the comments down below. Like this video if it gave you value. Subscribe if you want to see more stuff. Content like this, coding stuff, gaming stuff, all that type of cool stuff. Check it out in the description down below as well. Hit the notification bell to know when the next upload is. This outro is getting really, really long. Thank you so much for watching. Until next time, everyone. Thank you.